All right, so we're going to start chapter 7, and chapter 7 deals with rational expressions. So what I did was I outlined each chapter, and I'm going to put some keywords, so please copy this down. So in section 7.1, what we're going to do is we're going to deal with the fundamental property of rational expressions. So what we're going to look at first is we're going to evaluate a rational expression. So, and whenever you see evaluate, the textbook's not going to tell you this. What I want you to think of is to plug and chug. So whenever you're asked to evaluate in this class, what you want to do is you want to plug and chug. The next thing that we're going to look at with the fundamental property of rational expressions is we're going to factor. And then we are going to simplify rational expressions. And we're going to do this by canceling, which I'll show you what that means in just a little bit. Alright, and 7.2, we're going to be multiplying and dividing rational expressions. So the first thing that you have to do is you have to factor. After you factor, you cross, cancel. And then if you're using division, you're going to keep, change, flip. Just like if you were to divide fractions, you keep, change, flip. So and that's what you learned in 94. This section is super important. So section 7.6, I'm sorry, 7.3, it's going to set us up for the rest of chapter 7, and we're going to deal with least common denominators. So whenever you have least common denominators, first thing you want to do is you want to find the LCD. And you do this by factoring. Then you ask how many. And then you multiply the factors. So least common denominator, we call it the LCD. We talked about that a little bit at the end of chapter 6 and 6.5. In 7.4, we're going to be adding and subtracting rational expressions. So when you add or subtract rational expressions, the first thing you have to do is you have to find the LCD, just like you would with any type of fraction, and then you apply to the numerator, and then you add or subtract. Okay, so if you know how to do 7.3, you're going to be great for 7.4. And then 7.5 is just a little bit more of an expansion of 7.4. So basically what we're going to have is we're going to have big fractions, and we're going to be asked to simplify them. Okay, these are going to look super intimidating, but I promise you they're not bad if you take it one step at a time, which I have a trick for that as well. In 7.6, we're going to be solving equations with rational expressions. So in 7.1 to 7.4, we're going to have expressions. And whenever we have an expression, all we have to do is we have to simplify. That's what our directions are going to be. In 7.6, now what we're going to do is we're going to see equations. And whenever you have equations, what they're asking you to do is they're asking you to solve. So just like we did in 6.5, you're going to have to solve the equations. Okay, now the key that I want you to see with outlining this is we have to factor, factor, factor. We have to apply the factoring. We have to apply the factoring again. So chapter 6 with factoring was super important. So if you didn't get it, you need to go back and watch those videos or come see me and I can answer some questions for you, because factoring is going to be super important. So for today, I need you to get out your factoring as fun worksheet just to have beside you so that you can go to it with a reference. Alright, so the goal for today is to do 7.1, so the fundamental property of rational expressions. Alright, a rational expression is an expression of the form p over q, so it's going to be some type of fraction, where p and q are polynomials, and q does not equal 0. So first thing, let's talk about what a polynomial is. Okay, polynomial just means many terms. Okay, so if you have a polynomial that has one term, we call that a monomial. If we have two terms, we call it a binomial. And whenever we have three terms, we call it a trinomial. Okay? If it's more than three, we just call it a polynomial for now. If you get in more advanced mathematics, then they'll tell you what that polynomial is really called. Okay, so we've got some type of fraction where we have polynomials, so we see variables in it, and our q, our denominator, cannot equal 0, because if we have our denominator to equal to 0, then it's going to be undefined. So the first thing that we have to do with rational expressions is we have to evaluate. Whenever we evaluate, we plug and chug in the rational expression using order of operations. So this is where we do the please, excuse, my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction. Remember, when you're dealing with multiplication or division or addition or subtraction, you always work from left to right like you're reading a book. That's a common mistake that I see. So whatever you see with multiplication and division, you work from left to right. Addition and subtraction, you work from left to right. Okay, so let's evaluate it. If I have 5x minus 2 over 4x, I see that I have two terms on the top, so that's a binomial, over a monomial because it's one term. So what we're going to do first for a is we're going to let x equal 2. So wherever we see x, we're going to plug in 2. So I'd go 5 times 2 minus 2 over 4 times 2. Alright, and to evaluate this, we've plugged, now we get a chug. Alright, so 2 times 5 is 10, so 10 minus 2 over 2 times, 4 times 2, which will leave me with 8. Alright, and 10 minus 2 would be 8 over 8, which would simplify to be 1, because anything over itself is 1. Alright, so now let's do b. We're going to let x equal negative 3. So I've got 5 times negative 3 minus 2 over 4 times negative 3. Positive times a negative is a negative. 5 times 3 is 15 minus 2. Positive times a negative is a negative. 4 times 3 is going to be 12. So if I clean this up, that's going to be negative 17 over negative 12. Now, whenever we have a negative over negative, that turns into a positive, so it would be 17 over 12. And I am a-okay of you leaving it right like this, or if you want to turn it into a mixed fraction, it could be 1 and 5/12. Do you have to do that? Absolutely not. If you leave it as an improper fraction that is reduced as much as possible, I'm good to go. Okay? Now, let's do some reminders. Are we ever allowed to divide something by 0? No. Okay? And it should just be divide, not divided. So, can you divide by 0? No. Fractions are just dividing, right? So if I had like 8 over 2, that's just, fractions are just dividing. So 8 divided by 2 would be 4. Is that a true statement? Yeah. So yes. Therefore, 0 cannot be in the denominator of fractions or rational expressions. And if a 0 appears in the denominator of a fraction or a rational expression, we call this undefined. Okay? And I saw this trick once. So it's okay to have a 0 in your numerator, but it is not okay or no to have a 0 in the denominator. So if I had like 0 divided by 2, since my 0's in the numerator, it's okay, so that would just be 0. But if I had negative 3 divided by 0, no, I'm not allowed to have 0 in the denominator, so therefore my answer would be undefined. If you just leave it like this and not simplify it all the way, then you're going to end up getting a fourth of a point off. So please make sure that when you have a 0 in the numerator or denominator that you simplify as much as possible. Alright? So now what I want you to do is I want you to pause the video and I want you to do A and B. Okay, so if I have x squared minus 9 over x squared minus 4, I've got two terms, so that's a binomial over a binomial. So the first thing that I've got to do is I'm going to let x equal 2. So I'm going to go 2 squared minus 9 over 2 squared minus 4. 2 times 2 is going to be 4 minus 9 over 4 minus 4. and I've got negative 5 over 0. Remember the OK and the no. Since I have a 0 in the denominator, that's not okay, so my final answer would be undefined. Okay, now I'm going to let x equal negative 3. So I'm going to go negative 3 parentheses squared minus 9 over negative 3 parentheses squared minus 4. Negative 3 squared is 9 minus 9. Negative 3 squared is 9 minus 4. 9 minus 9 is 0. 9 minus 4 is 5. So 0 divided by 5 is 0. So these are my two answers. Hopefully you did okay with it. So the first thing that you have to do on your homework is you have to evaluate. And remember, whenever you see evaluate, you want to plug and chug. And there will be an A and a B. Alright? So now what we got to do is, when is the rational expression undefined? To answer this question, you set the denominator, I need you to change this for me, not equal to 0, and solve for the variable. Because, remember the OK and the no? We do not want to have a 0 in the denominator. If we do have a 0 in the denominator, it's called undefined, and we don't want that to happen. So if I have x plus 2 over x minus 5, and I'm trying to figure out where it's undefined, we don't care about the x plus 2, but we do care about the x minus 5, because we can't have this equal to 0. So what I do is I set my denominator right here, not equal to 0, and then I solve for the variable. So I got to get x by itself. So I would add 5 on both sides. So x equals positive 5. So as long as x does not equal positive 5, I'm going to be good as gold for this equation. Because if I have x equal positive 5, 5 minus 5 gives me 0, and it's undefined because we cannot have a 0 in the denominator. Okay, so you're going to have two questions like this on your test. You're going to have a question like this on your final as well. So what we're trying to do is we're trying to figure out where our rational expression is going to be undefined. So if I have 3r over r squared plus 6r plus 8, what I want to do is, I don't care about my numerator, I just care about my denominator, so I'm going to go r squared plus 6r plus 8 cannot equal 0. Alright, so this is where the factoring is fun worksheet should come into handy. You got 3 terms, so if it's 3 terms, it either can be a equals 1, a doesn't equal 1, or a perfect square trinomial. If I look at this, I see that it is an a equals 1, so I set up my two binomials, not equal to 0. I go r, it's plus plus, so I go plus plus. Then I find the factors of 8, so 1 and 8, and 2 and 4. Signs are the same, so I have to use addition to get to my b, which is 6. So I would use the 2 and the 4, and it doesn't really matter what order it's in. So 2, 4. Okay, so now what I've got to do is I've got my factors not equal to 0. So now I've got to set each factor not equal to 0, just like I did in 6.5, sorry. Alright, to solve my first equation, I got to subtract 2 on both sides, so I've got r cannot equal negative 2. And to solve my second equation, I've got to subtract 4 from both sides, so r cannot equal negative 4. So, in this rational expression, as long as I don't have r equaling negative 2, or r equaling negative 4, it will work out just fine. But if it does equal negative 2 or negative 4, it would be an undefined rational expression. Alright, so go ahead and try C for me. Alright, so we got 5x minus 1 over x squared plus 5x. The only thing I care about is my denominator, so I'm going to go x squared plus 5x cannot equal 0. I see that I have 2 terms, so it either can be a GCF or it could be a difference of a perfect square. Clearly this is a GCF because I can pull out an x, and I'm left with x plus 5 cannot equal 0. So I set each factor not equal to 0. There's one solution, x plus 5 cannot equal 0. In order to solve this second solution, I got to subtract 5 on both sides, and I get x cannot equal negative 5. Hopefully you got that one right. Okay, so that's the next thing that you have to do. We have to evaluate, then we have to figure out where it's undefined, so you set the denominator not equal to 0 and then you solve it. And then the last thing that we have to do is we have to simplify, so we have to write the rational expression in lowest terms. So let's talk about this really quick. Anything divided by itself is 1. So if I have 9 divided by 9, that's going to be equal to 1. If I have x to the 4th over x to the 4th, that's going to be equal to 1. If I have, I don't know, 9,000 over 9,000, that's going to be equivalent to 1. Now, when you are simplifying a rational expression into lowest terms, what you want to do is you want to factor completely, and then you want to cancel anything that looks exactly the same. Okay, so think about reducing fractions. If you have 30 over 32, yes, I do understand that you can use your calculator to plug it in, and then go math fraction, and then it will simplify the fraction for you. But when we're dealing with rational expressions, that's where we're going to see the variable. So it's going to be important that you know how to do this process. So if you have just a whole number, just like we did in chapter 6.1, what you have to do is you have to do your factor tree. So factor tree for 30, factor tree for 72. So for 30, that would be 2 and 15, because it's even. And then it would be 3 and 5. Remember, the reason why that you could stop your factor tree is when you have all prime numbers, which 2, 3, and 5 are absolutely prime numbers. So now let's do 72. 72 is even, so I'm going to go 2 times 36. 36 is even, so I'm going to go 2 times 18. 18 is still even, so I'm going to go 2 times 9. And then 9's not even, but I can go 3 and 3. And remember, I have all prime numbers, so I'm good as gold there too. So now what I've got to do is, since I used my factor tree to find the factors, what I want to do is I want to write those terms out. So I'm going to go 2 times 3 times 5. And then for 72, I'm going to go 2 times 2 times 2 times 3 times 3. Now, step 2 says cancel anything that looks exactly the same. So my 2's, one group of 2's are completely the same. One group of 3's are completely the same. So all I'm left with on the top is 5. What I'm left with on the bottom is 2 times 2, which is 4. And then 4 times 3, which is 12. So if you were to plug in your calculator, it would reduce down to that. If you did math fraction, if you use your factor tree, you factor it out, then anything that looks exactly the same, you cancel out. Alright, let's try another one. So we got 14k to the second over 4k to the third. The reason this is a rational expression is because I've got a monomial over a monomial. So what I want to do first is I want to find my factors of 14, and I want to find my factors of 4. So for 14, that would be 2 and 7, and those are both prime numbers, so I'm done. And then for 4, that would be 2 and 2. So I would go 2 times 7, and then 2 times 2. Now, in order to cancel out your k's, there's 2 different ways to do it, and I'll show you both ways. For me, it's easier to just take my least exponent, and my least exponent here is k to the second. The least exponent is just your smallest exponent, so I'm going to go k to the second. But if I have k to the third, so if I have k to the third divided by k to the second, I'm going to still be left with a k, because 3 minus 2 gives me 1, so I need to still include that k right there. Now, since I've factored it completely, what I can do now is I can cancel whatever looks exactly the same. So on the top, I'm just left with 7, and on the bottom, I'm left with 2k. Now let me show you another way to do it. Okay? You could go 2, 7, and then 2 times 2. What I saw last quarter when I taught this, you could go k times k because there's 2 k's, and then you can go k times k times k because there's 3 k's. So this completely works for me. You cancel out the 2's, cancel out a set of k's, cancel out another set of k's, and you're left with 7 over 2k. For me, this way it makes sense. If this way makes better sense, then go ahead and do it that way as well. I don't care. Either one's completely fine. As you see, you get the same exact answer. Alright, so let's look at B. So we've got 4y plus 2 over 6y plus 3. Alright, first thing I noticed, I got two terms, so that is a binomial over a binomial. So whenever we have two terms, it could either be a GCF or it could be a difference of perfect squares. I see for both of them that that they're addition, so difference of perfect squares out because it's not subtraction. So my only option is a GCF. So if I've got 2y or 4y plus 2, the only thing I can pull out is a 2, and I'm left with 2y plus 1. For 6y plus 3, again it's going to be a GCF. I can pull out a 3, and I'm left with 2y plus 1. Now, I factored it, so now anything that looks exactly the same can cancel out. So what can cancel out here is the 2y plus 1. And I'm just left with 2 over 3. I honestly like binomials and trinomials better than I like monomials, just because I think it's a little bit less work. Okay, now this doesn't mean that your numerator and denominator are going to be the same way to factor. So that's why that factoring is fun worksheet is going to be super important for you. Okay, like this one. So we've got a squared minus b squared over a squared plus 2ab plus b squared. Alright, so the first thing I got to do is I got to factor it. When I have two terms, it could either be a GCF or a difference of perfect squares. I see that it's subtraction. I see that those are perfect squares, so this is a difference of two perfect squares or just a perfect square. So I take the square root of a squared, which is a. I take the square root of b squared, which is b. I set up my binomial. I go plus, minus, and I got a plus b, a minus b, and I factored my top. Now to factor the bottom, I've got a squared plus 2ab plus b squared. I see that I have three terms, so I got a trinomial, so it either can be an a equals 1, it could be an a doesn't equal 1, or it could be a difference of perfect squares. That is not right. A perfect square trinomial. So if I look at this one, if it's a perfect square trinomial, the first and the third term are going to be perfect squares, which a squared and b squared are definitely perfect squares. And then my middle term is going to be even, which that's totally the case. So this is a perfect square trinomial. So what I would need to do, and I need to show these steps, is I would take the square root of a squared, which is a, the square root of b squared, my third term, which is b, and then I've got to check it. So I had to go 2 times a times b. And remember, the 2 comes from, it's got to be even. Alright, so then this would be 2 times a times b, which this completely checks out. So I would go my binomial squared, and then the sign I keep is from the first and the second term, so it's going to be plus, and I go a plus b. So what this a plus b squared really means is it means that I would be writing it twice. So I'm going to go ahead and do that just to make it look a little bit clearer. You can just keep the 2 up there if you prefer. It's kind of just up to you. I just like things to be as clear as possible. Alright, so now I've factored my top, I've factored my bottom. So now what I've got to do is I've got to cancel anything that looks exactly the same. So my a plus b looks exactly the same. So I'd go a minus b over a plus b. Now, if you want to keep the parentheses, that's totally fine. If you don't, that's okay too. Either way is a-okay. Alright, think you can do D? I want you to try. So pause it and go ahead and do it. When I have 5x to the 5th over 10x to the 3rd, first thing I see is I have a monomial over a monomial. So I've got to try to do my factor tree. But my factor tree for 5's already prime. So there's nothing that I can do with that one. For 10, that would be 2 and 5. So I would write 5, and then I would do 2 times 5. And now, you can either write the x 5 times and the x 3 times on the bottom, or you could take your least exponent, so I'm going to go x to the 3rd over x to the 3rd. But now I've got to figure out what I need to have x to some type of power, and how I would do that is I would do x to the 5th minus 3, so that would be x to the 2nd. That would be my leftover. Now I can cancel whatever looks exactly the same. The 5 looks exactly the same, and the x to the third looks exactly the same. So I'm left with x squared over 2 as my final answer. Hopefully you got it well. Alright, now, the last thing that we have to deal with simplifying is quotients of opposites. Okay, and a quotient of opposites is if the numerator and the denominator of rational expressions are opposites, as in x plus y over y, x minus y over y minus x, then the rational expression is equal to 1. So we know, or equal to negative 1. So we know that like 7 over 7 equals a positive 1. Whenever we have opposites, what ends up happening is they will reduce down to negative 1. Okay? And how you see that is you have two terms. It's always subtraction, and those terms are in opposite positions. Okay? Now, I'm going to show you a proof really quickly. So if I take my numerator of x minus y, and I multiply it by what it's equal to, negative 1, I can distribute this negative 1. So negative 1 times x, negative 1 times negative y. And if I clean that up, that would be negative x, negative times a negative is a positive, y, which would end up being y minus x. So it does clean up together because they're opposites of one another. So what I want you to notice is how the y's are in opposite signs and the x's are opposite signs of one another. So this x is going to be positive, this y is negative. This y is positive, this x is going to be negative. They are opposites of each other. The big thing, it's not as easy to see, but it is going to be super important to notice opposites because opposites always simplify to negative 1. And I usually put that negative 1 in the numerator. Alright, so I did an easy one to begin with, and then we can work on it in just a second. So this one I've already factored for you. So I've got 5 times x minus y over 3 times y minus x. So the first thing that I see is I see that they are opposites of each other. So using subtraction, they are in opposite positions. So opposites will simplify to negative 1. So 5 times negative 1 is negative 5 over 3. Now you only put the negative in the top, or the negative 1 in the top, because if you do a negative over a negative, that's going to give you a positive. Alright, so if we do a full problem, here we go. We got 25x squared minus 16 over 12 minus 15x. So I got a binomial over a binomial. So if it's a binomial, it can either be, which means two terms, it could either be a GCF or it could be a difference of perfect squares. So 25x squared minus 16, 25 and 16 are absolutely perfect squares. So this is going to be a difference of perfect squares, and we have subtraction. So I take the square root of 25x squared, which is 5x, take the square root of 16, which is 4, put my parentheses, go plus minus, so I've got 5x plus 4, 5x minus 4, and I've cleaned up my numerator. Now I've got to clean up my denominator. I've got 12 minus 15x. So if I look at 12 minus 15x, I've got two terms. So if I've got two terms, it either can be a GCF or it could be a difference of perfect squares. 15 is definitely not a perfect square, so what that means is all I can do is a GCF. And the greatest common factor that I can pull out is a 3. And when I pull out a 3, I'm going to be left with 4 minus 5x. Alright? That's really bad. 4 minus 5x. Okay, so if I look at this, if I quick look at this, I would say nothing simplifies. But if I look at it a little bit closer, I've got 5x minus 4, and then I've got 4 minus 5x. And we know that those are opposites of each other because the terms are in opposite positions and they're using subtraction. Okay, so whenever I have opposites, they simplify to negative 1. So what I have is I have negative 1 times 5x plus 4 over the only thing that's left in the denominator is a 3. And that's perfect. Now, if you want to distribute the negative 1, With the numerator, you can. You don't have to. I'm not going to take off with rational expressions. As long as it's simplified as much as possible, I'm good to go. Alright, so I need you to go ahead and practice this homework and bring questions when I see you next time. Thank you.